Hello, welcome to module 2. So in this module, we're going to talk about one of the key things in software quality assurance and testing. It is a concept called verification and validation, or V and V. Okay, so let's get right start at this concept. So there are two words, verification and validation. So let's start with verification first. So for verification, the definition says it is a process of determining whether the product at a given phase fulfill the requirements. Okay, so we make sure whether our software fulfills the requirements or not. Usually the verification activity is done by the development team. Okay, the developers are the one that verify the software at any given phase, during the requirement phase, during the design phase, during the implementation phase, and testing. Usually, testing is considered as verification because you check the correctness of the software by yourself. So verification, we ask ourselves whether are we building the software right according to the requirements. Okay, so that's verification. The second one is called validation. So validation is the process of evaluating the software at the end of the software development to make sure that it complies with the intended usage. So to make sure that it complies with the intended usage, you need to actually ask the customers about that. So you ask the customer to check your software and make sure that this is something that they actually want. So for this one, you answer the question of, are we building the right software? So building the right software or not, that depends on the customers. You might build the software right, but you might not build the right software, right? So I have a quick question here. If you already have the requirements, which we already asked from the customers anyway, why we still need to do validation? Okay, let's pause the video for a minute, think about it, and then come back. Okay, so I asked, if we get the requirements from the customer themselves, why do we still need to do validation, asking them again? The problem here can be because of the requirements itself can be wrong, or it can be incomplete. So you might not actually rely on fully on the requirements, because if you only follow the requirements, and if the requirements are wrong or the requirements are incomplete, finally, when you build a software, it might not be the one that the customer actually want anyway. So the better way is we do this kind of verification and validation together. So during the development, you do the test by yourself. And when you finish, let's say one feature, you go to see the customers and let them check, get their feedback, and then you come back. So the modern software development using the methodology like agile software development, we would have this loop of verification and validation mostly all the time. So you make sure that the software is correct according to the requirements, and you also make sure that it is what the user actually wants. Okay. In this case, in this course, if you study unit tests, integration tests, system tests that are performed by the developers, these are verification. And when you do user acceptance tests, that will be the validation. Okay. So it goes along with this concept of V model. So this is called the V model. I think because it looks like a V shape. And on the left, you have the development activities. And on the right, you have the corresponding testing activities that come along with each development activity. So we start by having the requirements. And then you move to the high-level design, like the architectural design. So you think about the architecture of the system. And then you do the detailed design, like classes, methods, so on and so on. And then you perform coding, which is the lowest level of development. So for coding, you have unit tests that checks the correctness of the code. That is verification. You have integration tests that check the correctness of your classes or the module. So this is also verification. You have a system test that checks the architecture and everything from end to end. This is also verification test. And the last one, when you have the acceptance test, you go and ask the users whether this is actually the software that they want. You want to check whether it conforms to the requirements. This is the place when it is validation. Okay. You will see that the dark arrows here shows the verification and the light arrows here show the validation. Okay, this is a very similar diagram showing starting from system spec, coming down to subsystem design, go to the unit level of the code, and then you have the unit test that checks these units or components. You have integration tests that check for the correctness of the interfacing between subsystems. And then you have the system test that checks the correctness of the system as a whole. And when you deliver the package, you do user acceptance tests that you check for the actual needs and constraint. Okay. So the verification, we can do multiple ways. We can do testing, we can do code inspections, which we're gonna also cover in this course, and you can do some static analysis as well. So we're gonna try also some static analysis tool like SonarQube. And for validation, this include the usability test or to get the user feedback. So this is mostly when you dealing with the actual users and then you ask them to play the software and then you collect the feedback from them. Software itself has some special characteristics, and these characteristics can make verification and validation more difficult than other kind of engineering products. The first thing is that the software has many aspects of quality requirements or the non-functional requirements, like scalability, security, reliability, so on and so on, right? The second thing is the software is evolving over time. Let's say you build a car. When it's finished, that's the car, and user just use the car. But for the software, is evolving over time. So the software itself can keep changing, and mostly when you keep changing the software itself is deteriorating as well. The structure of the software might get worse, and it might collect bugs, so on and so on. And it also has this problem of non-linearity and uneven distribution of the faults. So for example, if you have an elevator, which is also another engineering product, if the elevator say it can carry a load of 1,000 kilograms, you can make sure that if the people who get in the elevator do not have the total sum of their weights more than 1,000 kilograms, then the elevator should work fine. But if you have a software and it say that the software can correctly sort a set of 256 elements, it doesn't guarantee that the array with the smaller size than that, the software will perform correctly. It might fail on any specific amount of elements as well. So this kind of uneven distribution of fault make software very special compared to other types of engineering products. Okay. And the verification and validation also depends on the specification. So if you have an elevator, the response time when you press the button and wait until the elevator comes to see you can be considered as quality requirements or non-functional requirements. And this thing is a bit difficult to judge whether it is fast or slow, similar to getting the elevator. Somebody can wait for quite a long time, while somebody can wait only a short period of time. So we need to depend on the specification. We need to make sure that the spec indicate very precisely what's the number in there. The web page should respond in 3 seconds. The system should query the data within 15 seconds, so on and so on. Okay. So in order to do this kind of verification and validation, what are the information that we have? We have many information. So we can have a spec, software spec that written the information about input, output of the software. We can have the design or architecture of the software, and we can use it to guide our verification and validation. You can have the usage or the historical data of using the system. And one of the most important artifacts that you would have is the code. Okay, but sometimes the code is also not available. Like if you have only the binaries of the software, and you can rely on some experience of the people in the organization. So next, I would like to talk about the normal standard testing activities that would occur in any software company. You would start by having this phase one. You try to model the environment of the software. So when you start testing, you need to select what is the right abstraction of the interface or the software part that you want to test. The second one is you select the test scenario or you select the test cases. How would we select the test cases? How would we generate the test cases? And phase three, you run the test and you evaluate those test cases. So whether the test success or fail, and how do we know that when we should finish? How much test do we need? The last one is we measure the test, how do we know whether we test enough? Like testing and we get the correct result of 80%. Sorry. Is that enough or not? Now, so that's the question about adequacy. We're going to talk about all of these things in this course in the next following modules as well. Okay, so here is an exercise that you can try. Okay, so you are asked to test a method called triangle.scalene method. It accepts 3 integer numbers and it returns a Boolean value. The Boolean value should indicate whether that is a triangle or not. So the triangle, the scalene method will return true if P, Q, and R are the length of the side of the scalene triangle. So if you get the scalene, which means the triangle that does not have any equal side at all, then it returns true. In other cases, it returns false. So let's take some time and come up with the test set for such a method. Your test set should be something like this. You get P, Q, and R, and then you get the result whether it's true or false. Okay, let's pause the video and think a bit about this. Okay, to sum up, building a software is an engineering process, and we need to do 2 things, which is we need to do verification and we need to do validation to ensure that the software follows the requirement and it also the product that the user wants. And there's no single technique for all purposes. So we need to select the right test cases using the information that we have to test the software. So this module ends the overall concept of testing. And in the next following module, we're going to start talking on the actual techniques on designing the test cases and performing the tests. See you in the next module.